So, good evening all. My name is Paul Stevens. I'm the chair of BCS Nottingham Derby. And tonight, it's our last event before the summer, when no doubt you all want to go on your holidays, wherever that might be, or just watch the football. So, tonight's event is Authoring Natural Language Requirements of Ears by Mav, who you can see on the screen. And I'm just going to go through a few slides, and then there will be the main presentation and then question and answers at the end. However, Gary, who's assisting me, will be moderating the queue. So if you have a question, just put it into the chats. There isn't a separate Q&A box on here, so we've got to look at the chat queue. Right. So just some netiquette. Can you please make sure that you have your microphone on mute and your video off during the presentation, though? Mav might be happy to see a few faces. That's up to you, Mav, whether you want to see people's faces or not.
Yeah, could do. Yeah.
Okay. So questions in the questions pane if available, but it's not. So please put them in the chat. Can I ask you also to be aware of other people in the session? You know, you be welcoming and respectful. We've all got different views, and please be understanding of differences. And if you can be friendly and patient, especially when waiting for a question to be answered. Be open to all viewpoints. And please, finally, be kind and considerate of others. Next slide. We like to try and collect information. So can I ask you to lift your phones up and scan that QR code? It's just to answer a few questions. Some of it's about inclusion and diversity. Some of it is about how to help us plan future events. So I'll just give you another 20 seconds or so to scan that. As I say, it's quite a short questionnaire. We'd be really grateful if you could complete it. And if you can't scan the QR code, Gary, can you put the URL into the chat, please? Thank you. Okay. So just to let you know, I encourage you, if you're not a member, to join the BCS Nottingham Derby. It's an opportunity to develop yourself, especially if you join a committee. You can learn new skills. You can find details of our aims, who's in the committee, our annual general meeting minutes, and any events that we've had in the past, because they're all videoed and you can access them at your leisure. And it also advertises what we've got coming up. We've also got a LinkedIn group, BCS Nottingham Derby, which you can request to subscribe to. Just some advice for our next event, which is in September, on September the 20th. It's non-Azure machines with Azure. So we've lined up a guy who's pretty au fait with how to configure Azure Arc for managing non-Azure machines. So that's going to be in September, and you can actually register for that now. So go over to the presentation. So Mav, over to you. If you want to start sharing your screen, I'll stop sharing.
Okay.
Okay, we're clear. I'll see your screen.
Okay, thank you very much. So here we are, easy approach to requirement syntax, ears. That's what we're going to be talking about today. So obviously it's a relatively short presentation, so it's going to be rather introductory, but I'm going to give you some insights into what ears is. So the outline of what I'm going to talk about today, a brief introduction to who I am. I'll give you a list of some of the people who use ears to show that it's widely used in industry and academia across the world. I'll suggest why people might want to use ears, briefly talk about how ears was developed, and then the meat of it, I suppose, is talking about the ears template itself, so the generic ears template, When you apply the ears template, there are a number of patterns that emerge. So I'll discuss each of the ears patterns and give examples of each. Some lessons learned from applying ears from myself and others who've applied ears for quite a long time now. Some of the benefits of ears, and then a blatant sales pitch at the end, and some stupid pictures. I like to have pictures in my presentations, and here's one of them. So I do that thoughtful face, kind of taking the piss out of people who think they look clever on their LinkedIn pictures and stuff, looking thoughtful. And that's just a shop I found with something approximating my name, so that's why that picture was taken. So who am I? Yeah, so my name is Alistair Maven, generally known as Mav. My main experience that's relevant here is 14 years at Rolls-Royce. Before that, I worked at City University in London, mainly transferring research into industry, so in effect as a consultant. I also worked at Practice Critical Systems, who became Altran UK, who I believe are now part of Capgemini. That was also as a requirements specialist. And then for about the last 3 years, I've been self-employed, doing consulting in requirements engineering, quite a lot of training in ears and requirements engineering in general. Yeah, so that's what I do. I've written quite a lot of papers. I'll give a link to my ResearchGate later. And this is some of the companies that use ears. So most of those companies or organizations I have trained in ears or presented to in ears. Some of them are companies that have come across ears through my presentations at conferences or have found my papers online and have basically taken it in-house and delivered training that they've developed themselves. But all of those companies use ears quite extensively. There are quite a lot of companies that are not on there. There are some that I've only heard sort of second, third hand, so I'm not going to cite them because I'm not certain that they're using it. And I've no doubt there are more companies than that. Every time I go to a conference, I hear of more companies who are using ears. It's quite widespread, the use of ears. One of the reasons why it's widespread is because people like it. Why do people like it? Well, people like natural language. Most people write most of the requirements in natural language, and ears is essentially a gentle constraint on natural language. So it's not particularly far removed from natural language. The only real difference between pure natural language and ears is a few rules that say you put clauses of a sentence in a particular order and you use a few keywords in a particular way. And those keywords and the way they're used is very close to their normal everyday use. So it's not a stretch. It's not really much. It's not far from pure natural language. So people like natural language, and essentially people want it easy. People don't want a heavyweight notation. They don't want to pay for a new tool. They don't want to learn some complex modeling language. So people like natural language and they want something easy. So lots of people advocate the need for doing requirements engineering. Vanilla Ice was one such person. The first line of Ice Ice Baby, well, he says Ice Ice Baby a couple of times, but the first proper line is stop, collaborate, and listen. So I think it's pretty clear that he was talking about the need to understand your stakeholders before you start writing a set of requirements. It's all about listening. So a little bit about how ears was initially developed. So it was developed while I was working at Rolls-Royce, when myself and some colleagues were interpreting CSE, Certification Specification for Engines, which is an EASA, European Space Agency. It's an EASA regulation to which all aircraft have to comply, all aircraft engines, in order to be able to fly in European airspace. So we were reading the content of CSE to try and unpick it into the requirements on the engine control system. So it was a cross-discipline team of engineers. So there was a general systems engineer, a safety engineer, myself as a requirements engineer. Airworthiness engineers were called on quite extensively, because obviously if you start trying to interpret a regulation and say, well, we think it means this, and therefore we're going to build this product that's going to address that clause of a regulation, then you've got to make sure that you're making a good interpretation of it, because otherwise you might not satisfy the airworthiness regulations. So the airworthiness engineer was a crucial stakeholder in that, and where necessary, we called in subject matter experts on particular functions or pieces of hardware or whatever that maybe had some insights that the rest of us lacked. So we had a cross-discipline team of people, and we went through clause by clause through CSE. And worked out what were requirements and what were not, and the ones that were requirements we started rewriting into simpler requirements. How did we do that? Well, we had a simple set of rules, a relatively loose set of rules. I mean, I should perhaps backtrack slightly. We didn't set out in any way to come up with a new notation. We just set out to do some work and to write clear requirements. So we didn't really have a set process. We kind of made it up as we went along, if you like. And so we had a loose set of rules, which were, I suppose, my knowledge and received wisdom of how to write requirements well from my experience, and of course that of the other people involved. But I was the main requirement specialist. So we started with a loose set of rules, and then as we went through each of the clauses of CSE and tried to interpret them and write them into the simplest, clearest requirements that we could on the engine control system, at least in the first pass that we did, we just looked at control system requirements. As we looked at different cases, we refined the loose rule set, and it gradually sort of coalesced into something that was coherent, and that we were then applying the same set of rules. Those rules became tighter, and we applied them in a consistent way across all the examples that we came across. Interestingly, several years after first writing the year's paper, I was at a conference and sort of accidentally went into an event on grounded theory, which was something I hadn't known about. And grounded theory, apologies to anyone who knows grounded theory in any detail. My simple understanding of grounded theory is you look at data, you hypothesize about what's happened, you infer possible rules on the data that you see, and then you see whether that works on other sets of data. And in a sense, we did grounded theory, but without realizing it. So we just set out to do some work without hypotheses, as it were. So CSE, Certification Specification for Engines, as many regulations and many high-level source documents that you might want to interpret for requirements, is what you might call a rich mixture, which is being polite, of statements of different types. It includes high-level goals, objectives, needs, wants, wishes. It includes things you might recognize as requirements on the system under consideration, in our case, the jet engine or the engine control system more specifically. And it will include requirements on other systems. So even though it's about the engine, it includes requirements or implied or explicit on other systems. So there are things that are requirements but aren't on the system we were building. It includes domain statements, so statements of fact or assertions about the world, about the world in which your system is going to operate, that this document is asserting are true. So they're not requirements, but they're statements that are being made about the world. Assumptions, so unsubstantiated in some cases assumptions about various things. Information, so things that are none of the above, but are just introductory text or whatever, or waffle in some cases, etc. So there's a lot of stuff in there. So one of the key things that we had to do, of course, was work out what were requirements, and then of the things that were requirements, what were requirements on the engine control system. So I won't go into the detail of exactly how we did it, but simply we put each clause into a cell of Excel, and if there was a clause of CSE that had an introductory text and then lots of bullets, we'd take the introductory text and then the first bullet and concatenate that into one potentially atomic requirement, and then the introductory text and the second bullet, etc. So we divided things into what we believed were individual statements, categorize them as goal, requirement, etc. If they were requirements on the control system, we would then interpret them in what eventually became years. So the Spice Girls are here because the Spice Girls are a bit like Vanilla Ice were into requirements engineering. The song "Wannabe," "Tell Me What You Want, What You Really Really Want," is clearly a song about goals. So I use that as a slightly silly example, but I think one of the most important things in requirements engineering in general, and of course, if you're doing EARS, you're doing requirements engineering, is to recognize the difference between goals and requirements, which I think is really important, and people often don't make a clear distinction between them. In my opinion, goals and requirements are very different things that should be handled in different ways. So I use that as a silly example. Tell me what you want, what you really, really want, or a silly as in a non-engineering example, but it's a hook that people remember as a way of categorizing goals and requirements. And that's just a very, very noddy way of saying that you need to do a lot of stuff before you start writing your requirements. This is not a presentation about requirements engineering in general. This is a presentation about EARS. So if you're going to start writing EARS requirements, you will hopefully have a clear idea of what your system is for, its purpose, who the sponsor is. You'll have a clear system boundary defined, etc., etc., and then you're going to start writing requirements, potentially using EARS. So having applied this loose rule set to CSE and having refined it during the ongoing study, we realized that the requirements that we were producing were all in a very similar structure. We were using a few words in a very specific way and very consistent way each time, and that there was effectively a small number of patterns coming out that all textual requirements, at least in this set, seem to follow. So all requirements followed one of 6 basic patterns. And then having done that, we hypothesized that maybe you could apply that to other sets of textual requirements and the same set of patterns would also apply. And to cut a long story short, that's true, that does work. So we subsequently wrote a paper, and a co-author actually had to convince me that it was worth writing a paper because I didn't think it was that different to what had gone before, and I thought it was almost too obvious and too simple to be of value. It turns out it's actually precisely that simplicity that does make it of value. One of the reasons people like EARS is because it is very simple. Anyway, I'm now going to explain a little more about what EARS actually is or how it works. So EARS is a template. I actually started using the word template and then sort of somehow regret it, but it's now become known as a template. The reason I'm cautious about the word template is it can sound a little bit like a checklist type thing where you fill in each section in a very procedural manner, as if you take your brain out and just follow it brainlessly. It's not really like that. It's more a kind of a framework, if you like, but it's become known as a template. So the EARS template is made up of simple clauses, and those clauses are always in a specific order. By clause, I mean a chunk of a sentence. Each part of a sentence is always put together in the same order. And there's an underlying rule set that governs what is mandatory and what is optional. So depending on the EARS pattern that is applied, some of those clauses are mandatory and some of them are optional. And as I think I've already said, if you apply the EARS template to a textual requirement, the requirements that come out of that fall into one of a small number of patterns, depending on which of those clauses are applied. So this is a very simple way of showing you, guiding you through the different EARS patterns, the different EARS types, is to use these triangle brackets to denote the different clauses. So in the following examples that I use, those triangle brackets will denote a clause, and anything that's in bold is mandatory for that particular pattern, EARS pattern, and anything that's in normal font is an optional clause for that particular EARS pattern. And then purely for the purposes of explaining it in a presentation like this, I use superscripts to show the mapping between the generic pattern and the examples. You wouldn't do that if you were using EARS for real. It's just to, in practice, it's just to show you how the two relate to each other to illustrate the examples. And here's, if you like, the cardinality or the rules for an EARS requirement. Each requirement must have 0, 1, or many preconditions. I'll talk about what preconditions are in more detail in a moment. But there may not be any preconditions. There can be one. There can be more than one precondition. There can be 0 or 1 trigger. There can never be more than one. So it's either 0 or 1 trigger. And I'll explain what a trigger is in more detail. There is one and only one. There must be a system name. So which system is responsible for delivering this requirement when it becomes active? And there can be one or more system responses. In practice, it's usually one or possibly two system responses, perhaps 3. One or many is theoretical. It's not often that you'd have many system responses. So for example, sometimes a system will need to take some action and display a message. So it's doing 2 things. That's a typical way in which it may do more than one thing in response to the requirement becoming active. So here's the very generic EARS syntax, which some people find a little abstract when written like this. Most of you being computer science people or people interested in computers are probably quite comfortable thinking abstractly like this. If you're not comfortable thinking in these abstract terms, the examples in a minute will perhaps make this a little clearer. So this is the generic syntax that applies to all EARS requirements. So the precondition comes first. So the keyword while preconditions are true, when trigger is detected, the system name shall system response. And you'll notice that system name, shall, and system response are bold. So all EARS requirements of whatever pattern must have a system name, must have the keyword shall, and must have system response. Setting aside the fact that people use different keywords instead of shall, let's assume there's an imperative, and I personally favor shall. It could be must, may, if you prefer that. So there would be an imperative of some sort. So what's a precondition? A precondition is conditions that must be true for a requirement to become active. So they are things that are true, that persist over a period of time, that must be true, and as long as that is true, you want your system to behave in a particular way. A very simple example from aerospace is while an aircraft is in flight. An aircraft is in flight for a period, and you can test, you can monitor whether it's in flight. While it's in flight, you might want certain behaviors. A trigger is a discrete event that's detected by the system against which you want the system to respond. So when a trigger is detected at the system boundary, you want the system to do something. So when that trigger is detected, the system will become active, or the requirement will become active, and you want it to respond in some way. So of course, there may be preconditions that must be true before the trigger is detected, which would be specified in the requirement if they were needed. The system name must be explicit, by which I mean you shouldn't just say the system shall, you should name explicitly the system. And that's a rule of EARS, and that's because requirements are often reused. They might be reused between different projects. They might be reused in different documents within the same project, perhaps applied to sent to different suppliers and so on. And if, for example, if you think about a jet engine fuel system, there might be, there might be some requirements on the whole engine that relate to fuel. There might be some requirements on the fuel system. There might be some requirements on the fuel pump. There might be some requirements on the fuel metering valve. There might be some requirements on some pipes that to do with fuel, or some brackets to do with fuel. If all those requirements at different system levels just said the system, then it wouldn't be clear at what level they applied and which system was responsible for carrying out that system behavior. So it's a rule of EARS that all requirements must have the system name explicit. The system response defines what the system must do when that requirement becomes active. And one of the reasons why EARS is quite intuitive and people find it easy to pick up, as I said, is because it mirrors the normal use of the words, but it also mirrors temporal logic, the order in which things logically happen. So while something is true, when something is detected, this named system shall do this thing is intuitively logical because it's the order in which things happen. So when writing requirements in ears, there are two broad classes or categories, if you like, of requirements that emerge, which are normal operations. So that's requirements for the wanted behavior or sunny day scenario, if you like. So this is requirements for how your system should behave when all interacting systems, users, environment, and so on, everything behaves as you'd expect it to, and want it to achieve the desired user or stakeholder outcome for a particular interaction with the system. So if you like, sunny day behavior. So if everything goes according to plan, how would you want your system to behave? And then the rest, if you like, is what's called unwanted behavior in EA's terms, and that's requirements that are used to specify how you want your system to behave in response to anything unwanted, unexpected, or undesired in the domain. So anything the user does that you wouldn't want or expect to happen, anything that happens to any interacting system if they behave in ways that are unexpected or undesired, or the environment or anything undesired on it. So that therefore a rainy day scenario. That they produce requirements of different patterns in ears, but it's also quite a useful way of dividing up your effort when you're eliciting and possibly even documenting your requirements, to think about normal operation first, and then in a separate pass considering doing some what-if analysis and thinking what could go wrong, which yields ears unwanted behavior requirements. So yeah, just a token picture of a bit of aeroplane. Just to say that EARS was developed at Rolls-Royce and has been used by numerous safety critical organizations. So it's whilst it's relatively easy to apply and relatively lightweight in the sense that it's not very formal or heavyweight to apply, it does work, it does scale, and it does work in safety critical domains. So the normal operation patterns, so these are the types of requirement that you get for normal operation when applying EARS. Ubiquitous, so these are requirements that are always active. They are things that the system must always do. And I'll explain each of these with examples in a moment in subsequent slides. State-driven requirements are denoted by the keyword while. So while some precondition is true, the system must behave in some way defined by a state-driven requirement. So these requirements remain active as long as that precondition holds. Event-driven requirements, which are denoted by the keyword when, they define the required system response when a triggering event is detected. So the easiest example to think of there is in a customer-centric system. If a customer presses a button, that's a discrete event that happens once, or when it happens, it's a tangible, specific, discrete thing. When that happens, you want the system to respond in some way. And state-driven and event-driven requirements are in effect the vanilla building blocks out of which you can construct more complex system requirements. So for most systems of any complexity, the majority of requirements actually have a precondition and an event. So they have a state and an event. So they'll tend to be while some state is true, when some event is detected, and they are called complex requirements in EARS. So they use combinations of those keywords. And then the other normal operation pattern is an option requirement, which I don't cover in much detail in this presentation simply because of time. And they use the keyword where, and that's just a very simple mechanism to handle product or system variation. There are many ways of handling product and system variation, and if you've got a very complex product line, this wouldn't be the way to do it. But if you've got a few very simple options, it's a very lightweight and simple way of doing it, and that's covered in several of the papers about EARS, but I don't cover it here just because of time. So ubiquitous requirement in a little more detail. So this is the simplest EARS pattern. So it's got the least clauses. So the system name shall system response. So these are requirements that define continuous system behavior. Put continuous in inverted commas because software engineers think of continuous functions in a subtly different way, and I don't mean it in that sense. It's something that the system must always provide, so that it's not qualified in any way by some state being true or some event must happen. It's just something the system must always do, if you like. So as an example, the ATM shall use electrical supply from the national grid. So I'm using the tagging there, the superscripts 1 and 2 to show that ATM is the system name and use electrical supply from the national grid is the system response. And then that's the plain text. That's exactly the same requirement. And as I said, I only use this tagging to show how that requirement maps to the general pattern. And the thing about EARS requirements, as I say, is they're very intuitive. So the way that's written, the ATM shall use electrical supply from the national grid, looks very much like natural language. I mean, it effectively is natural language. So the person reading it doesn't need to know that it's written in this thing called EARS. That's an interesting thing about EARS as compared to some notations. Many notations, you have to go on a training course, you have to buy a tool, you have to get a very bad headache, you have to spend a long time learning to be able to write the requirements. And then the poor person who's got to read it has got to do some training to actually understand it and be able to read it. EARS, you need relatively little training to actually write EARS requirements, and almost better still, those reading it don't even need to know what EARS is. You can just read it because it's very close to pure natural language. So state-driven requirements, so these are denoted by the keyword while. So while some preconditions are true, the system name shall system response. So all those are in bold. So for this particular pattern, you must have all those clauses. So these requirements are active while the defined state remains true. So they're continuous as long as the precondition remains true. So while the bank system is processing, the ATM shall display processing, please wait. Again, the same text, just without the tagging. Event-driven requirements are denoted by the keyword when. So when some trigger is detected, the system name shall system response. So these requirements are initiated only when the triggering event is detected at the system boundary. So another useful side effect of EARS is because you have to explicitly name that trigger in order to be able to write this requirement, that can help for system decomposition, that you must have some means of detecting that event that's in the trigger. So you may need some sensor or switch or something to be able to detect that event, and that must be at the boundary of the system. So when that event is detected at the boundary of the system, EARS also helps with black box thinking. You sense that event at the boundary of the system, and then you want your system to respond in some way defined by the system response in the requirement. So when the customer enters the withdrawal amount, the ATM shall check the customer balance. So again, it looks very simple, just how you might write it if you just wrote pure text, but there's actually some structure and some rigor to it, although it still reads pretty much like natural language. So complex requirements are basically combinations of the EARS keywords, as I say. So while preconditions are true, when a trigger is detected, the system name shall system response. So these are combinations of the EARS keywords. So while a transaction is in progress, when cancel is pressed, the ATM shall return the card on display. Please take your card. So here's an example of a system responding with there's two system responses in response to that requirement becoming active. It both returns the card and displays a message. So I was looking for amusing images of ATMs since I'm using ATM examples. So that's just a silly picture of an ATM. There's no more to it than that. So unwanted behavior is basically how EARS handles any events that are unwanted or undesired. There's a fuller definition of what unwanted behavior is in the first EARS paper, which is just called Easy Approach to Requirement Syntax. Again, just to repeat, all of my papers are available from ResearchGate, and I'll give the link to that at the end. Or the simplest thing is go to ResearchGate and put in my name. You can find it easily. That's one of the advantages of having a relatively unusual surname. So yeah, unwanted behavior is a general term for all undesired or unwanted events that you might have to handle. So any failures or disturbances, any deviations from desired user behavior, any undesired or unexpected behavior of any interacting systems, including the environment and so on. So anything goes wrong, inverted commas, how would you like your system to behave in response to that? So it's the required response of your system to these unwanted external events that obviously your system must be able to detect. An unwanted behavior can be used along with the other EARS keywords to specify more complex unwanted behaviors. So there may be preconditions, but they're optional. So that's in normal font. So while preconditions, if there are any, if trigger, then the system name shall system response. So the keywords if and then differentiate this from an event because it's effectively an unwanted event. And just the part of the power of that again is the simplicity of it, but the keywords if and then just flag up to the person reading it that this is a mitigation. This is a requirement to handle something that you'd rather doesn't occur. So the if defines effectively an unwanted trigger. So it's a variation of the event-driven requirement, but just with different keywords. So if the withdrawal request exceeds the balance, then the ATM shall display balance exceeded. Another silly ATM picture, quite like that one. So requested $2,200. Sorry, we cannot process your request. You are drunk and you do not need to buy everyone in the bar shots. Pay tab or call cab. Probably Photoshop, I suspect, but funny nonetheless. Okay, so some lessons learned from EARS. Now there's a paper called Lessons Learned, which is a very clever pun, which I'll refer to in a moment. And these are some very simplified some of the lessons from that paper. And the Lessons Learned paper was 4 practitioners from 4 different organizations. Or 3 different organizations, 2 different parts of one organization, between them with 8 or 10 years experience of using EARS, and we sort of pooled all our knowledge of how to apply EARS and the good and bad things people find from applying EARS, and these are some of them. So one of the key things is, and while trying to infer or capture EARS lessons learned, we also captured some other general lessons for any natural language requirements notation or requirements engineering in general. So these aren't necessarily all purely about EARS, but they're relevant to the application of EARS. So one of the key things is to recognize the different types of statement, and not everything that is dressed up like a requirement in a document actually is a requirement on your system. So categorizing those statements as to whether they're goals, tell me what you want, what you really, really want, which are aspirational and stretch targets and may not be achievable, they're goals. You don't write requirement statements for those because they're not requirements. System requirements, you do write requirement statements for. Domain statements, you don't write requirement statements for because they're not requirements. Information is not a requirement, don't write a requirement for it. So categorize these statements and understand them with the stakeholders to make sure you get them right, and only write requirements for the ones that actually are requirements on the system being developed. When you write your requirements in EARS, challenge them. You may have got them wrong. It's very common for people to write, when they're first using EARS patterns, to write all the requirements as if they're ubiquitous. But you should go, well, hang on, is this always true? Oh, maybe it's only true when certain states in the world exist. So maybe it should be state driven. Is it in response to some trigger? It should be an event-driven requirement, and so on. So whatever pattern you try, challenge it and see if actually it might not always apply or might not be in the appropriate pattern. EARS helps you look for pairs. Pairs is in inverted commas because there aren't always 2 of them, but in simple terms 2. So a very simple example, if you're writing requirements for an aircraft, you might have some requirements for in-flight. Well, if you've got some requirements for in-flight, are there similar circumstances on ground that you might need to consider? If you're writing requirements for while the engine is running at idle speed, do you also need to consider at high idle or low idle or at climb, at other conditions? So looking for pairs or sets of requirements. EARS, because of the clauses, just tends to make you think about some of those other states and events that may be relevant. EARS tends to work well alongside models. So because you have event-driven requirements, they map very nicely to any form of scenario, be the activity diagrams, sequence diagrams, however formal your scenario is, you can use it to elicit EARS requirements. If you've got a set of requirements, you can put them in a model. So you can start with the requirements and put them in a in some sort of scenario, or you can start with a scenario and use that to generate requirements. Either way, I'm a big fan of using different approaches to cross-validate that you've got the right information. So EARS works with scenarios, EARS works with state charts and numerous other models. And the EARS patterns work well with that. For example, you could use a state chart to generate to make sure you've got a full coverage of a certain situation if it's an inherently state-driven system. But perhaps if some of your stakeholders aren't familiar with state charts, you might want to write the requirements in EARS so you can parse your state chart and use it to write EARS requirements. Or indeed, if you want to write requirements in EARS, you can use a state chart in the background to help validate and make sure you've got the right set of requirements, even if you don't need to show your stakeholders it. Requirements evolve over time, and EARS allows you to add more detail as you get through your requirement solicitation and analysis. Typically, people write draft requirements and then improve them over time. So there's nothing wrong with having a TBC, in my opinion, in a requirement, as long as you've got a plan to resolve it. I've mentioned already that it's a useful way of chunking up your effort to initially do your wanted behavior and then separately go through your interaction with your proposed system again to consider unwanted behaviors. And obviously those map very nicely to the two broad types of EARS requirements. You do the wanted behavior first and then the unwanted behavior with if-then requirements as a second pass. It's always worth considering if a requirement should be split. If you're struggling to put a requirement in EARS, some of the reasons can be that it's a goal or it's a domain statement, or you're not sure what your system boundary is, or you're not clear about something, or you're not clear about the states in the domain of your system. So you need to understand more, or you're trying to write a requirement that should actually be two requirements, and you're trying to shoehorn too much into one statement. So sometimes requirements should be split. And coaching to embed the learning is quite useful. One of the things about EARS, and it's perhaps my fault that the E of EARS is easy, people think it's easy, and it sort of is easy. It's easy to pick up. It's easy to get some benefit from applying EARS, but to do it well takes a bit more effort. You get a lot of value from the initial uptake of EARS, but to do it well and consistently does take some practice, and some coaching is a good idea. So that's a reference to the Listen to Learned paper, which is from RE16. So you can find that from ResearchGate, as I say. So some of the benefits of EARS, there are many, and they're detailed in the papers as well, but this is a summary of the main ones, if you like. EARS has been shown by some of the early papers. We showed it with our work within Rolls-Royce, but it's also been shown by other companies in many other papers, other studies in other companies, that EARS reduces and in some cases even eliminates some of the common errors in natural language requirements. So in the first paper, we identified 8, and then the second one, I think, we identified 8 very common problems in natural language requirements. Vagueness, ambiguity, overspecification, so on, duplication, lots of these things, and all those we eliminated several of those types of errors, and we radically reduced the others. So all 8 were significantly improved. Some of those errors were eliminated, and that's been shown in numerous other studies. One of the benefits is that you don't need a new notation or tool to learn or document using EARS. You can use the principles of EARS on the back of a cigarette packet. You don't need any sort of tool or notation. Very little training is needed. You can get some benefit from EARS from an hour or so's training. I mean, some of you may go and use EARS from this half hour or so. It'll be enough to get started, if you like. The resultant requirements are consistent in style. One of the things people often say is that requirements, even if written by different authors, if they're following the EARS patterns, are more consistent between different authors. An individual will write more consistent requirements if they're using EARS, but also, and perhaps even more significantly, different authors writing using EARS will write requirements that are much more consistent than they would have done otherwise. And the other side of that is that they're also universally understandable because they're effectively in natural language and everyone can read that. It's been found to be especially useful for authors who have to write in English, but whose first language is not English. A colleague of mine from the requirements circuit who works for Intel, Intel have trained, well, this is old information, 5 years or more ago, they had trained over 10,000 people in EARS. So it's probably 15,000 people by now, maybe more, I don't know. They've trained a lot of people in EARS. And they've, this colleague I know from the requirements conferences, they were saying they were on a project where there were, I think it was 15 different first languages on a project they were working on. And of course, everyone has to communicate in requirements written in English. And they found, and they were using EARS, and they found that the consistency and the clarity of communication was it's like off the scale in terms of how much better it was than in previous projects because of the simplicity and clarity of using EARS, even for people whose first language isn't EARS, first language isn't English. I've said already it works well alongside models. And people have found that it's an effective bridge between informal and formal. So you can write requirements at a very early stage in a fairly informal way, but you are applying a certain amount of rigor. So it moves you towards being a little bit more formal. And as such, it helps promote black box systems thinking. Another soundbite somebody said once is that it's almost like a gateway drug to more formal approaches in a good way. So why use EARS? Well, I said people like natural language and people want it easy. Well, EARS is natural language and EARS is easy. But there's an Italian proverb that says making wine is simple but not easy. And I think that's kind of the way it can be with EARS. I mean, I've said that the E of EARS is easy, but that can be slightly misleading. A requirement written in EARS is easy to read, but that doesn't necessarily mean it's always easy to write it. Because to write an EARS requirement, you have to understand your system reasonably well. Another quote from a senior engineer in a blue chip engineering company you will all know, but I'm not allowed to mention his name or the company name because they don't allow that in that company. He said, if you can't write it in EARS, you don't understand it. If you can't write it in EARS, you don't understand it. So I've had people say in the past, oh, EARS isn't very easy. It's not very easy to write because I can't write this requirement I want to write. And under cross-examination, when I talk to the individual when they're saying that, quite often it's because they're a bit confused about their system boundary, or they don't really know what they want the system to do, or something's not defined properly yet. So the reason they can't write it is because they don't know what to write. It's not a fault of the notation. And actually sometimes the notation, the simplicity of it uncovers that lack of understanding. Anyway, making one is simple but not easy. So I've explained EARS on a very simple level, but to understand it well, you need perhaps a bit more training than this and potentially some coaching to embed the learning. So here's the blatant sales pitch. So in a couple of weeks, I'm doing an online training course, Writing Better Requirements with EARS. This is my normally pre-COVID one-day training course on how to write EARS, but I split it into 2 half days because it's online and no one likes a whole day of Zoom. So it's 2 half days. I'll give the dates and everything in a minute. Excuse me. And this is roughly what is covered in that session. So some of which we've covered today, but it'll be covered in more detail. So how EARS was developed, the motivation for EARS, the generic EARS template and the EARS patterns with examples, obviously in rather more detail than we've had today. I also talk about EARS for non-functional requirements. Some of the early feedback we got, people assumed and some people asserted that EARS only worked for functional requirements. I don't believe that's true. EARS definitely does work for non-functionals. That will be explained in this training. The advantages of using EARS, the limitations of EARS when it's not the most appropriate notation because it doesn't do everything, and a bit more detail on the industry practice. Now, although that's most of the bullets there, the last one is actually half of the course and is in a way the very important bit. So broadly speaking, the session as it is with 2 half days. The first day is the sort of theory and the classroom examples and some exercises, and the second half day is a full session of hands-on practice of applying ears in your own domain. So I encourage people to bring requirements from their own domain, so they're working on real work, real current project work with support to apply what they've learned. If people have IP issues or for whatever reason don't want to share their requirements or haven't got any, I can provide them. But most people prefer to bring their own real requirements. So that means you leave the training with a real working knowledge of ears in your domain. So it's writing better requirements with ears. It's online training. It's on Wednesday the 7th and Thursday the 8th of July at 1 till 5 UK time on both days. And just to be clear, it's on 2 days, but it is a single course. It is one course that you sign up for if you want to do it, but it's split over 2 sessions. The cost is $399, but if you pay by the 28th of June, which is a week today, by the end of the 28th of June, it's 15% off. It's $339. I haven't got a formal sign-up page or anything. I'm going low tech. If you want to attend, send an email to mav@alisonthemaven.com. Could we perhaps put that in the chat? I was supposed to remind you to do that, please, in case people want to copy paste it. So my email is mav@alisonthemaven.com. If you just email me and say you'd like to come, I will send you a PayPal request, and then obviously you get buyer protection with PayPal, etc. So contact details. So there's my email address again. My website is www.alisonthemaven.com, and there's an ears page which you can obviously navigate to, or /ears, and ResearchGate. There's the URL, but the simplest practical way of doing it is Google ResearchGate and then type in my name. All my papers on ears and else are available there. That was a very quick rattle through because it's quite a lot to explain in a relatively short time. That's my slides, and I will take questions now.
I'll say thank you, Mav. Mav did that presentation 5 years ago to the branch, and I can confirm I work for a European company in my day job. I taught some of those techniques, and I wrote some requirements for some new products and services, and it did work very well for especially with people who don't have English as their first language. So Gary, we're over to questions, please.
All right, so we got 7 questions and 6 minutes to rattle through those. So the first question is from John. Does ears align with SysML or UML modeling?
Short answer, yes. I've had discussions with people in the past. There are those who think model's good, text bad. I've had people say, if it's rigorous, it's got to be model, it's got to be formal. Well, model, in my mind, does not necessarily mean boxes. Model means some sort of rules and some sort of formality and something rigorous. So ears, in a way, is a model. It's a textual model. But also, SysML, I've never, put it another way, I've never seen a system specified with boxes and arrows. There have to be words as well. And ears requirements will go very nicely in those boxes because they have states and events and so on. So they map extremely well to everything within SysML and UML. So I think it works extremely well with SysML and UML, and plenty of people have applied it.
Okay, the next question's from Raphael. Is it possible to get several triggers for one given requirement using logical operators and or is only one trigger event possible?
Short answer, only one. The reason being that, right, slight disclaimer, I'm talking about at system level. In software, you may do something else. If I get time in my slightly less than a minute, I'll come back to that. EARS was originally developed for system level requirements, but has been applied by people at lower and lower levels down towards software. And obviously in some ways it's similar to pseudocode, so it does have some of the structures rather like software requirements, some are software requirements. But initially it was written for system requirements. And from a stakeholder perspective of what they want a system to do, they want to know, when this event happens, I want to see this response. And there may be another event that yields the same response, but they don't care about that at the time. If I do this, I want to see that. Oh, if I do something else, I also want to see that. And from a testing point of view, it's easier if they're atomic requirements. You do X and you see Y, you do Z and you see Y, whatever. So that's simpler from a user perspective. How you implement it in software, for example, if that's perhaps behind the question, you could have some logic that where there's one expression that would satisfy several EA's requirements. So in terms of how you implement it, you might implement it as one expression, but in terms of the actual need that a stakeholder has, I would say they would all be separate requirements. So in EA's terms, it is a hard rule. There is only ever one trigger in a requirement.
Thank you. Nick asks, on record requirements, do you also capture requirements in EA's format to do with aspects that are not the product function, but, for example, records that need to be kept, e.g., the system shall have documented test certificate?
Right. So that sounds. So that's not a system response as such. It's a requirement on the project to deliver some supporting documentation or something, is what I think that would be, that sort of example. You could write that sort of thing in EA's as well, yes. So I would, but the qualification there would be that the system name should clarify what is responsible for delivering that response. So if you're talking about a system that you're building, then it's the name of the system explicitly. If it's the project team shall deliver a set of documentation, or the project team shall deliver a user manual, then the system, the responsible system is not the delivered system, it is the team who are responsible for delivering it. So you can use them for that sort of thing, but you've just got to be careful what your quote system name is.
Very good. Next one's from Nathan. One problem we struggle with is compound requirements, and using EA's has helped. There is some question, however, about how to organize the requirements into a document that makes sense to read as a whole. Is it preferred to characterize or chapterize the sections to keep things readable, even while the discrete requirements are more or less standalone?
Short answer is probably yes. I think behind that is the fact that I'm not sure if this is answering the question, but it's something that it triggers in my mind. There is no correct way of setting up a set of requirements, because there will often be some requirements that want to be in more than one section. However you divide up your taxonomy or your sections within a requirement, there'll be some requirements that are relevant in several places, so you want to see them more than once. There will be some that don't really fit anywhere, so what do you have, a miscellaneous section? So there's no right answer for how to divvy up a set of requirements. But of course, any set of requirements for a system of any sort of reasonable complexity are almost certainly going to be in some software tool, and you'll hopefully only have one logical instance of it to avoid redundancy and inconsistency between the different versions of the same thing. So if you have one logical version of it, you could display it in different views. So for example, in DAWs, most of what you ever see on a screen is a view. It's a view of the database. So you can have things that are logically in different places, but shown together. I talked about scenarios, and scenarios are useful. So often, not always, but often it's useful to have a document that shows a scenario. And that's a logical way of showing how the requirements relate to each other whilst maintaining the atomic requirements, as the questioner said.
All right, thank you. We're almost out of time, so we'll go with one more. Isla asks, how do you cope with the fact that users will say everything they want is a requirement, even though you know some are goals?
Ultimately, a goal is an aspiration, a wish, a want, and it is something that's often a feeling. It's how you'd like to feel in the future, or it's unachievable. If you say to someone, how would you know when you've got that, and they can't really answer it, or if you ask 2 or 3 different people and you get extremely different answers, I think there are ways of discussing around it and getting people to recognize that some of these things are goals. Ultimately, I think requirements engineering is about managing people's expectations. And if you get people to understand that lots of people want lots of things, and not everyone can have all their own goals satisfied, because an individual's goals will include overlaps and conflicts and direct contradictions. Each individual will have that. So as soon as you get several people involved, there are bound to be lots of tensions between the goals, and getting people to understand that and saying, I know you want that, and you want that, and you want that, and you want this, this, and this. Right, this is what we think we could build, and you will get that satisfied to some degree, and this will address that to some extent. So it's partly about language as well. Requirements can be satisfied potentially if they're functional requirements, black and white, pass fail. Non-functional requirements, they're satisfied to some degree, whereas goals, I would say, are more addressed. You're not really satisfying them, because I want something fast or cheap or easy to use. You can't say it's past. It's relative. So I think it's just about getting people to understand that. So it's a soft skill. It's about getting people to understand. It's not a hard thing. That's not hard as in a firm thing. It is hard. It's difficult.
Great, thank you. We still have 2 questions from Nick and Shah. I invite you to send an email to Mav, and he will respond. Right.
Well, I would also say, if anyone has any questions that come to them in the next 10 minutes, hour, or week, or whenever, I'm always happy to field questions about ears. It's always interesting to me how people apply it, or want to apply it, or see issues with it, or whatever. I'm always interested to hear about people's thoughts. So you're very welcome to ask me questions.
Thank you very much.
Okay.
Paul, back to you.
Thank you, Gary, for asking the questions, and thank you, Mav, once again. 5 years later, I've got an excellent presentation once again. So thank you all for joining the session tonight. Our next event, as I say, is in September. If you want to book, it's open now. Other than that, have a good evening, and thank you for joining us.
Thank you all very much. And I mean it, email with questions. I'm not just saying it. Thank you.